Okay, before we start trying to explain one of the differentiation question, let's go back to the basis of indices. Okay, now some of the law of indices, let's visit them. Now x a, okay, can be written as 1 over x a. Put a minus. Why? You see, this xa is as the numerator of this fraction over 1. Now we are taking it from a numerator to become a denominator. So if that's the case, then you must change the sign. This is a positive a, you put a negative. Okay. Similarly, if I have x minus a, okay, if I want to make this as the denominator, so what I do is, remember we have to change the sign, so we put a negative. And then the original is minus a. Okay? So if that's the case, it becomes 1 over minus times minus become positive. So it becomes x a. Okay? So you can see, if you form a numerator which is negative, denominator negative, you bring it up to become a numerator, it becomes positive. Now, if you have a positive power or indices in the denominator, if you bring it up to become a numerator, then become negative. Okay, these are the very important rules. Now, second rule would be this. Okay, x, y, a, b. Okay, you see. Okay, now this can be written as x a times c dot b. This y b times c. So this is equal to x a c y b c. Okay. Now example. Let's look at one example. Now you have a 2 and an x 4. If I put 2 here, this is actually equal to 2, 1, x 4 is 2. Okay? Now, so it's 2, 1 times 2 dot y. This is equal to x 4 times 2. So this becomes 2 to the power of 2. This x to the power of 8. 2 to the power of 2 becomes 4 x 8. Okay? Now, so this is one of the rules. From here, you convert to, actually it's an expansion. Okay? From here to here is a simplification, removing the bracket. But sometimes you go the other direction. Okay, that means from this, you go to this. Now, for example, let's say, okay, 3 square, okay, time this 16. Now, this can be written as 3 square times 4 square. Okay, since they have the same power, I can rewrite this as 3 times 4 to the power of 2. Okay, so from this I can convert to this. So this is actually, if you start from this side, you can end up this. Okay, So this formula here can go either way. Okay, can go either way. You can sometimes from here to here is simplified, or sometimes you go this way to this way in order to simplify. Okay, now let's go for another one. The very fundamental. You got a times x b. Okay, now the condition for this to be able to combine this multiplication is that the base has to be the same. This x base, the x base. So x, the base must be equal. Then only you can combine the power. But in this case, it's multiplied, so it's plus. And then this b, so this answer. Okay, now, what about xa times x minus b? Okay, now, first we write xa. Now, if multiply means you plus, okay, xa plus the power of this, which is minus b, okay, and this is x plus times negative become negative, so it's a minus b. Okay, now okay, now let's say I have x, a instead of a whole number, let's say it's a fraction. Let's say this 2 over 3 times x equal to minus 1 over 3. So this is equal to 2 over 3 times means plus minus 1 over 3. So this gives you x 2 over 3, positive times negative become negative 1 over 3. So this becomes x 1 over 3. Okay. Now, if you x a divided by x b, then x a, because it's divide, so you have a negative. So this b, right over here, that's the answer. Now, what about x a divide x minus b? So this x a divide means minus. Originally it's minus b. You just write, just follow. So they become x minus times minus become plus. So it's a plus b. Okay. Now the next one is, if I have a x 0, I should end up with a 1. Okay. Okay, anything to the power of 0 is equal to 1. Now, another one is x a over b, where the power is a fraction. This can be converted into, the denominator is the b, so the root is b root. And then outside of b root, you put a bracket to indicate the power is a. Or what you can do is, you put x, put the power a in first. Then only you convert the root to p root of xa. That means the root comes first before, the power comes first. The a is the power. Then only the root. Either way, it should work. Okay. The advantage this over this is because you take the root and then you put in the power a. The number will be it's easier to You see, you take the root, this number, b root x, it becomes a smaller number, and then you a power of the smaller number. It's easy to get a number that is, it's easier to multiply and get the number that's required, okay, because this base here to this power a is much smaller. But in this case, you have to find x to the power a first. Then, but this, if the a is a big number, then you have to, you end up with a very big number here, and then you have to go and take the root on this big number. Sometimes it's easier to make a mistake in this way. Okay, so that's it. You remember all these points when you're doing some differentiation, whereby the power is a fraction. Okay.